Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salihuddin bin Azhari. Today I want to present about the assignment 1. For our group member is Helmi Syafiq bin Anwar, Muhammad Haris bin Zainuddin. The lecturer name is TS Dr. Muhammad Razali bin Muhammad Tomari. Okay. The assignment is to solve the engineering problem using the intelligent concept system. Concept. So my part is to do the Hebbian training algorithm. For the properties of Hebbian training algorithm is first, that has a random initial weight y equal t, wn equal w all plus nxy, bn equal b all plus ny, and the learning rates n equal to 0.5. So the value that have been given is x1 is 0, x2 is 0, x3 is 0, and x0 0 1 0 0 0 1 1 1 1 1 1 0 1 0 1. So t is a random value, so our group put t is for the class A is 1, and for the class B is 0. Okay, for the it has a 6 tier. You can see is 1 2 3 4 5 6. So x1 is the same as before, s1 s2 and s3. So the initial weight for w1 our group give the value -4, and w2 0, w3 -2, and beta is 1. So after we put this value on this equation, and we get the new value is -4, 0, -2, and the beta, we use this formula, beta new equal to beta all plus ny. So after that we get the negative 1.5. So on the, we repeat the same step for 0 1 0. So the t we get the 1, y equal to t is, so y equal to t is y equal to y is 1, so the t is 1. -4 0.5, -2 2. On the 3 0 0 1 1 1 1, -4 0.5, -1.5 2.5, 1 1 1 0 0, -4 0.5, -1.5 2.5, 1 1 0 0 0, -4 0.5, -1.5 2.5, 1 0 1 0 0, -4 0.5, -1.5 2.5. Okay, we open the Excel. So the data is equal to 1. So in this step, 0 0 0, y is 1, t is 2 0.00. So this 0, this 0, and this 0, and beta is 1, beta is 2.5, so we put this 2.5. Okay, 0 0.5, x2 is 0.5 plus 2.5, and you get the answer is 3. So x1 is -1.5 plus 2.5, we get 1, and 1 1 1 negative 4 plus 0.5 plus negative 1.5 plus 2.5, we get negative 2.5. 1 plus 1, negative 4 plus 0.5 plus 2.5, we get negative 1. 0, 1, 0, 1, negative 4 plus negative 1.5 plus 2.5, we get negative 3. So the 2.5 is bigger than 1, so we put y prime is 1. 3 is bigger than 1, so we put 1. 1 equal to 1 is 1. Negative 2.5 is lower than 0, so we put 0. Negative 1 is lower than 0, we put this 0. And negative 3 is lower than 0, we put this 0. Okay, the next step is to find the coordinate, to plot the graph. So the equation is w1 x1 plus w2 x2 plus w3 x3 plus b theta equal to theta. So negative 4, we take this negative 4, 0.5, negative 1.5, 2.5. So we just put this value, negative 4 x1 plus 0.5 x2 minus 1.5 x3 and plus 2.5 equal to 1. So we put this 2.5 on the right side, and we put negative 4 x1 plus 0.5 x2 plus 2.5 on the right side. So that's mean that's 1.5 x3 equal 4 x1 minus 0.5 x2 plus 1 minus 2.5. So negative 1.5 we put on the s3 is equal 4 x1 minus 0.5 x2 plus 1 minus 2.5 over negative 1.5. After we solve this, we get this 2.67 s1 plus 0.234 s2 plus 1. And we solve the equation 1 plus 2.67 s1 plus 0.34 s2. We just put the value s1 negative 3 in s1 and negative 3 into s2, and we get this value negative 8 0.3, negative 5 0.2, negative 2.01, 1 4.01, 2.02 and 10 0.03. So we put this value on the MATLAB. So after we do MATLAB and we get this graph, so we can see the 3 10.03, 2 7.02, 1 4.01, 0 1, negative 1 negative 1, negative 2.01, negative 2 negative 2, negative 5.02, negative 3 negative 3, negative 8.03. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Zainuddin. Will present the Adeline training solution. Okay. This is the Adeline training solution that we use in Excel. First, we apply for up row to down row. This is the value class of 0 0 0 1 1 1. Week 1, week 2, week 3 is 1 respectively, and the value of bias also 1. Learning rate 0.5. Okay, after applying the calculation, we get the final value for the W1, W2, W3. For W1 1.06, 0.5, 0.3125 respectively, and final value for bias is negative 0.563. Okay, these are the value we are going to use to calculate the output. Okay, example here is x1 is 0, x2 is 0, x3 is 0, and we put in here as example 0 0 0, and we use this formula to calculate the value, and the value will be negative 0.5625. The value of summation is put in this table. Okay, now this can be applied to all the other row. Example is 0 1 0, so we just put here 0, and this is 1, and 3 0, and the value is negative 0.0625. Same with for the row 2. So all of the other column row we'll put in here. Now how can we get the y prime value is the value is compared with the threshold value. To get the threshold value, we must first select one of the value from the class A and one from the class B. This example here, I choose negative 0.25 and 313. This is smaller than 0.3.3 to get the 0.532, and the calculation do is actually we take this value and we minus with negative 0.25 they together and both two. Okay, and we get the answer at the theta. So all the summation will be done earlier. We will get the threshold value. Example, if negative 0.56 is smaller than threshold value, then the y prime will be 0. And same the others value. If negative 0.06, if smaller than 0.532, it will be 0. And more than the threshold value, it will be, we get y prime is 1. So in conclusion, the result that we get that 100% accuracy, since the value of t is equal to the value of y prime. And that's all for the Adeline training from up row to bottom row. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ilmi Shafi bin Anwar. My matrix number is DE170033, and now I want to present about how to find the Adeline. So we use the random value of Adeline. As you can see here, we separate the value of the class A and class B. So this is the value of class A. X1 is 111, X2 is 1011, X3 is 101, and the T is 000. For the class B, we use the X1 is 000, X2 is 010, X3 is 101, and the T is 111. For the value N, we use the 0.5. So this is the table we need to make. So how we want to make, we need to put the value of the x1, x2, and x3 for the class A and class B, and also the T. So we use the random value of the W1, W2, WT, and the bias. So first, we need to find the value of S. So how we want to find the value of S, we need to check the input of the x1, x2, x3. If the value of 1, x2, x3 is 1, so we need to add the value of the W1 equal to x1 and the W3 is equal to x3. So we need to add the negative 4 and negative 2. Negative 4 plus negative 2 and plus with the bias, y is 1. So that's why we get the negative 5. So next is we need to find the y, t minus s. T minus s is t minus with negative 5. So we get a 5. Next, we need to find the W1. So W1, the formula is W1 is W old plus with N is 0.5 times with the x we need like this is value, and the time is t minus s 5. So negative 4 plus with n 0.5 times with x 1 and times with t minus s 5. So that's why we get the negative 1.5. So next is the 0 w2. So w2 is same with the formula w0. So because it's the w all the 0, so and the value of x2 is 0 also, so that's why we get 0. Same with the w1. So next is w3. So w3 is negative 2 plus with the n 0.5 times with the x is 1 times with t minus s, t minus 5. That's why we get the 0.5. So next is the b, bias. So bias is bo, b all is 1 plus with the n 0.5 plus with the 5, t minus s 5. So that's why we get the 3.5. And next is we need to find the s. So s, same, we need to add the wx1 and x2. So negative 4 plus 0 plus n1. So that's why we get the value of 2. So y, t minus s, 0, 0 minus 2, we get the negative 2. And the w1, w all negative 1.5 plus with the 0.5 time with 1 and times with t minus s, negative 2. So that's why we get the 2.5, negative 2.5. So the w2 same, w all 0 plus with the n 0.5 plus times with the 1 and times with the negative 2. So we get the negative 1. So next is the 0 w3 is 0.5 plus with the 0.5 times with the 0 because the x3 is 0. So plus times with the negative 2. So we get the 0.5. So the bias is 3.5 plus with the 0.5 times with the negative 2. Then we get a 2.5 for the s. So negative 0.5, we get the negative 0.5. So we add x1, x2, and x3. So negative 2.5 plus with negative 1 plus with 0.5 plus with the 2.5 the bias. So that's why we get the negative 0.5. And the y, t minus s, t 0 minus with negative 0.5. That's why we get a 0.5. And this number w1, we need to the negative 2.5 plus with the 0.5 times with the x, f is 1, and times with the t minus s. This minus s is 0.5. So we get the negative 2.5 and negative 1 plus with the 0.5 times with the x, the value of x2 is 1. So times with the t minus s 0.5. So that's why we get the negative 0.75. And the w3 w all is 0.5 plus with the 0.5 times with the x, the value of x is 1, and times with the 0.5, and we get the 0.75. And the bias for b all is 2.5 plus with the 0.5 and times with the t minus s is 0.5. That's why we get the 2.75. And for the class B, 5, for the class B s, so we need to add the x1 x3 equal to w3 0.5 plus with the bias 2.75. So that's why we get a 3.5. And y t minus s 1 minus 3.5. So we get the 2 negative 2.5. And the w1 is same with the w all because the value of x1 is 0. Next is the w2 same with the w1. So the value of x2 0, so we get the value of W all. So next is the W3. So W3 is negative 0.5. How we get the negative 0.5? W all 0.7 plus 0.75 plus with n is 0.5 times with x3 is 1 times with the negative 2.5, then we get the negative 0.5, and then the bias is 2.75, the bias all B all, and plus with the 0.5 and times with the negative 2.5, then we get a 1.5, and the 0. For the S 0.75, so we need to add x2 and the bias. X2 is equal to W2 negative 0.75 plus with 1.5, then we get the 0.75, and the y is t minus s, 1 minus the negative 1 minus with 0.75, that's why we get the 0.25. So W1 is W is negative 2.25 because the value of the x1 is 0. That's why we get the value of the W all. So the W2 is W all is equal to negative 0.75 plus with the 0.5 times with the x1 and times with the t minus s 0.25, then we get the negative 0.625. So the W3 is same with the W all because the value of x3 is 0. So next is the bias. Bias is V all 1.5 plus with the n 0.5 times with the 0.25. That's why we get the 1.625. Okay, next is the value of S. So because the value of the x1, x2, x3 don't have the value of the x1, x2, x3, just we get the bias number 1.725, and the y equal to 1 minus with t minus f s, we get the negative 0.625, and w1 because the x1 is no value, we get the w all value to negative 2.25, same with w2 and w3, okay. And the bias is 1.3125 because the W all 1.625 plus with the 0.5 and plus with the 0.5 minus with the T minus S negative 0.625. So that's why we get the 1.3125. Okay, right, for this value, so we need to add the last value of the x1, x2, and x3. So the value of x1, x2, x3 and t equal to w1, w2, and w3, and the bias, the last value of this. So for we need to add the negative 2.25 plus with the negative 0.5. So that's why we get the negative 1.4375, negative 1.4375, and this value is negative 2.25 plus with the negative 0.625, then we get the negative 1.5625, and this is we need to add the W1, W3, W1, W2, W3. So but negative 2.25 plus with the 0, negative 0.625 plus with the negative 0.5 is why we get the negative 2.0625, and this we need to add the value of the x3 negative 0.5 plus with the 1.3125, so that's why we get the negative 0.8125. Okay, alright, for this we need to add the negative 0.625 add with the 1.3125, then we get the 0.6875, and then this we just get the value of the bias. Okay, how we get this value, we need to use this formula w1 x1 plus vw2 x2 plus vw3 x3 plus with a bias. Okay, right. So we add the value, use this value, the number of the upper and the lower. So next, this is the graph value that we get from the value of the x1, x2 and x3. Okay, right, next we use the MATLAB software to plot the diagram of the adenine. This is the coding that we need to use, and this is the value of the x, y and z. Okay, right, as you can see here is the value, the scatter plot diagram of adenine. As you can see here, the value of the x, y, z is equal to x is x1, y is x2 and z is the x3. Okay, right, that's all. Thank you.